Right, up next we've got question 5, and the big key of question 5, always I like to make a note to myself, I mean it's not a note to myself, but a mental note, is that I'm looking at f prime. That's going to be key as we work through this problem. So let's find all the points where f is a relative maximum. Now, just remember that a relative maximum occurs where f prime changes from positive to negative. So we can make a sign chart of f prime of x. And so we just have -3 where we started, and it changes signs at -2, or it has critical points, or it's 0 rather. F prime is 0, those are critical points at these indicated values. So we have our endpoints and our two critical points, -2 and 1. So let's see what's going on here. F prime is positive above the x-axis from -3 to -2, then it's negative from -2 to 1, and it's negative again. So x equals -2, since f prime of x changes from positive to negative. So I'll just say, so f -2 will be a relative max, right? So it's based on the fact that you're looking at f prime of x. Now again, it's where is this graph above and below, and then you're doing that analysis. All right, part B. Part B, on what open intervals is our graph concave up and decreasing? Okay, well, we still need to analyze our slope here. Let me see here. How can I know? Just reading through the rest of what they gave me. Okay, all right. So we have our f prime of x, and we're also going to need to consider f double prime of x. Now again, we have our same intervals as before. We have -3, we have -2, we have 1, we have 4. We still need all the super important points from f prime of x before, but now let's notice something else. They tell us all about these horizontal tangents at -1's not going to be there. Why do I do these so late or early in the morning? I don't know. -1 and 1 and 3. Okay, so let's see what's going on in this crazy sign chart. F prime of x still is the same behavior, so it's positive, and then it's negative all the way through. Now f double prime of x. Now this is where things get tricky. F double prime of x, remember you were looking at f prime. So f double prime is asking you about the slope of this graph. So the slope is negative until it gets to -1. Then it's positive until it gets to 1. Then it's negative until it gets to 3. And then it's positive until 4. And so, let's see here, what we can see is these are our open intervals, where it's both decreasing and concave down. So the intervals -2 to -1, and 1 to 3 have f prime of x less than 0, and f double prime of x less than 0. In other words, decreasing and concave down. Okay. Big key to that question is noticing that the horizontal tangents and the fact that you're looking at f prime, you're not trying to find where this graph changes concavity. You're trying to find where this graph changes from decreasing to increasing, because you already are looking at f prime. That's the big key there. Caught myself for a second thinking about that. Okay, speaking of which, find all the points of inflection. Well, we have them right here, here, and here, because that's where f double prime changes signs. So x equals -1, x equals 1, and x equals 3. At these points, double prime of x changes from positive to negative, or vice versa, or negative to positive, however you want to say that. Right, so in other words, that's where f double prime of x is changing signs at these 3 points. So from negative to positive, from positive to negative, and then back from negative to positive. Okay. And of course, they need to be considered because that's where f prime of x is 0. Or sorry, the tangent of f prime of x is 0. All right. Last but not least, okay, part D. Ooh, part D is your fundamental theorem of calculus question. Now, it's fundamental theorem of calculus. It's also kind of new position because if you want to find any new value of x, you need to know where you last were. You need to know the x value, where that last occurred, and you need to know where you want to go. Now, because I'm already using x's, I can't use like f prime of x dx. I need to use f prime of t dt. All right, so in other words, x is already a variable. You need a different variable for your integral. But if you want to know where you want to end up, you need to know where you last were and how much you want to change your x values by. You need to integrate the rate of the function you want, so f prime. Okay, so that's our integral expression, fundamental theorem of calculus essentially, with the last occurring value. And now it's time to find f of 4. Well, that's going to be 3 plus the integral of 1 to 4 of f prime of t dt. And, well, that makes sense why they gave us these values. Now, notice that they say that they're 9 and 12 respectively, but they're also implying that you realize that it's really -9 and -12 because they're below the x-axis. So we have 3 plus, so from 1 to 4, whoops, that is -12, so we get -9. For f of -2, integral of 1 to -2, f prime of t dt. This one's going to have one extra little catch. It's really 3 minus the integral of -2 to 1. It's going to go in numerical order, which means you switch the signs. You can switch the bounds, but you have to switch the sign in from the integral. So now we really have 3 minus, and -2 to 1 was really -9, so now it's -9. So we get 12. Okay, let's check ourselves and see what we did. Okay, so identify -2 and give a reason. So the reason is the sign chart in this phrasing right here. All right, I got my correct intervals of concave down. I gave my reason. The sign chart is kind of your reason there. Part C, okay, we have these 3. They break it into like 2 paragraphs, but I just kind of said vice versa and everything, but there we go. So now notice I argue it because f double prime changes from positive to negative. They argue it by saying f prime changes from increasing to decreasing. I think both are valid, but both are correct ways. I mean, in other words, I think you still get points by saying this. Okay, integral expression. Again, make sure you have the dt's. You can't use x's everywhere. You can't integrate to x and like have an x. And yep, -9 and 12. Cool. All right, there we go. One more.